Good evening and welcome to the second Math Monday session. So I am your instructor, facilitator, tutor, whatever you want to call me, Miss Charles. And today is going to be a pretty long session. So of course I'm going to go over the objectives before I start. But just to give you a quick rundown, last week or last session we'd have looked at the classification of numbers. And we ended on an introduction to fractions. That's where we ended last week. So if you want to familiarize yourself with the topics that the topic that we covered, you can go on our YouTube channel and rewatch the live video that was posted. Of course, for this session, if you have any questions, concerns, feel free to leave comments. Or for those who have joined in on Zoom, you can send your messages in the chat. So during my session, camera will be off. So my apologies in advance. Also, I'm apologizing in advance for my background noises. All right, so let's jump right in. So for today, we'd like to look at what you are expected to know about a number. So that's the first thing we'll touch on. Then we will continue with fractions. So there's a lot about fractions that we need to know. I mean, fractions, there are a lot of real world applications for fractions. If you're a baker, fractions come in handy for when you have to do measurements for your ingredients. If you're a tradesperson, carpenter, plumber, seamstress, etc., you need to know your measurements. Fractions come in handy for that. If you're a doctor and you have to do dosages for medication, fractions also come in handy. Just overall calculations, finances, accounts, etc. If you, let's say you go to a restaurant with your friends and you all want to split the bill, fractions will come in handy for calculating and making those calculations. Calculating wages, anything like that. Those are some real world application of fractions. So we're going to look at fractions. Of course, we're going to cover the types of fractions. We're going to do addition and subtraction of fractions. I think we're also going to cover multiplication and division as well, although it's not listed there. Once we have enough time, we'll cover that. And then, of course, if time permits, we'll go into integers. We'll look at addition and subtraction of positive and negative integers, multiplication and division of positive and negative integers. So today is going to be a pretty long day. I am not certain we will be able to go into integers, but it's just there in case if time permits. So you're going straight in. So things you should know about a number. So let's just say we have any number. So the number 7. These are the things that you're expected to know. If you have any number and there's no sign in front of it, it's not raised to any power, these are the things that are known. So we don't write it, but if we had to put a sign, a power, division, we have to divide it by a number, multiply by a number, there are some things that would be considered to be obvious. So any number that we have, if it doesn't have a sign in front of it, it's understood that the number is a positive number. So a positive sign is understood. We don't usually write it because once we write a number by itself, it's understood that that number is a positive number. Another thing that is known that we don't write, or that should be known that we don't write, is that that number is raised to the power 1. So any number raised to the power of 1 gives you itself. So in this case, if we have 7 to the power of 1, that is the same as saying 7. That is why we don't write that power 1 at the top there. If we have a million and we raise it to the power of 1, it will remain a million. That is why when we write numbers naturally, so we learned about natural numbers last week. When we write numbers naturally, we don't put that power of 1 because it's understood that any number to the power of 1 is itself. Another thing that is known, any number, so a plain number without anything on it, is understood that that number is multiplied by 1. Because any number multiplied by 1 also gives you that number. So in this example, we have 7 multiplied by 1. 7 by 1 is 7. Similarly, if we divide by 1, so if we were to write that whole number 7, that natural number 7, and we wanted to put it as a fraction, we can write it as 7 over 1. The 7 divided by 1, 7 over 1, is the same as saying 7. So these are some things that you should know about any number. As long as you have a number and there's nothing in front or behind, above or below that number, it's understood that these are some of the things that you can write. A number by itself is a positive number. It is also a number that is raised. It is also raised to the power of 1, because anything raised to the power of 1 is itself. If it's multiplied by 1, it's also itself. And if it's divided by 1, it will give you back that same number. So those are things that you should. So we're going to go straight into fractions. So last week when we covered fractions in our introduction, we said that fraction is a number that consists of 2 integers, and they represent a part or a portion of a whole. And a whole meaning one whole piece or one whole, whatever it is, a whole meaning 1. That's what we said fractions were. Then we went on to look at a fraction, an example of a fraction, and talk about the parts that that fraction consists of. So the 2 integers that make up the fraction have names. The number on top is called the numerator. It represents the amount you have. The number below is called the denominator, and that represents how many parts you split your whole into. So if I have like the fraction there, 20 over 57, or 20 57ths, this is telling me that we would have split our whole into 57 pieces. However, we only have 20 of those 57 pieces. So that's just to recap what a fraction is. Next, we talk about the types of fractions. So we're going to look at unit fraction, whole fractions, proper fractions, improper mixed fractions, also called mixed numbers, like fractions, unlike fractions, and equivalent fractions. So the reason why unit fractions and whole fractions are in green or in teal is because those are things that we don't really classify it, but it is something that you should know. So it's there for just your information, for common knowledge, more or less. So unit fraction. So unit fractions are fractions with a numerator of 1. So doesn't matter what the denominator is, the numerator has to be 1. So unit, that term unit meaning 1, numerator of 1. So let's look at some examples. All of the examples on the screen in front of you, those are all unit fractions. So it doesn't matter what or how many pieces we've divided our whole into, as long as we have, because remember the numerator represents what we have, as long as what we have is just one part or one portion of that whole, then it's called a unit fraction. So the first fraction is 1/2, then we have a quarter, we have 1/100, 1/25, 1 over 999. Right, so all of these are called unit fraction. So as long as your numerator is 1, doesn't matter what your denominator is, it's called a unit fraction. Now let's talk about whole fraction. So whole fractions are fractions where the numerator and the denominator are the same value. So whatever integer we have, whatever two integers we are using to create that fraction, both of them are the same. These fractions are equal to a whole or one. So remember I told you a whole represents one thing, right? So unit fractions just mean that we have the same number on top, same number below. So numerator is the top, and denominator, when you think of denominator, to remember that name, think of down below. So the number at the bottom or down below is the denominator. So that's just an easy way to remember. And of course, if the one down below is the denominator, then of course the one on top has to be the numerator, right? So you're going to look at some examples of whole fractions here. We have 2 over 2, 4 over 4, 100 over 100, 25 over 25, and 999 over 999. So those are all whole fractions. Because if we divide 2 by 2, we'll get 1. If we divide 4 by 4, we'll get 1. If we divide 100 by 100, we also get 1. 25 over 25, 999 over 999. All of those will give us a whole. So these fractions are equal to a whole or 1. So it doesn't matter, once you work it out, you will get 1. These are called whole fractions. So these two, so unit fractions and whole fractions are just basically for common knowledge. We just have to be able to identify that, okay, this is a unit fraction, this is a whole fraction, but we will rarely ever encounter them because we will just simplify them. So next type of fractions we're looking at are proper fractions. So proper fractions are where the numerator is less than the denominator. So the numerator is less than the denominator. So let's look at some examples of proper fractions. So all of the fractions in front of you, if you look at the denominator or the numbers or the integers down below, all of them are larger than the ones on top. So these are called proper fractions. So think of it as a cone balancing. If you have a cone, if the cone is upside, if the cone is right side up, sorry, it will not balance. But if you have it like this, other way, with the wider part, the larger part below, it would balance, right? So proper fractions are like a cone that is balancing. If we want it to balance, we put the larger portion at the bottom. That's a way to think of it. Think of it as a cone, and we're just going to put the larger piece below so that it balances. Larger piece. So proper fraction. Larger, the numerator is less than the denominator, or the denominator is larger than the numerator. Okay, so next we're going to look at improper fractions. So of course, improper fraction is just the opposite of proper fractions. So the numerator is larger. So let's look at some examples. So if we look at all of the examples, you will see that in the top, the numerator, the numbers on top, sorry, they are all large. So the numerators here in these examples are larger than the denominator. So these are called improper fractions. So it's basically just the opposite of proper. Now we talk about mixed fractions, which are also called mixed numbers. These are numbers that consist of a whole number and a proper fraction. And we're going to look at some examples. So a whole number along with a proper fraction. So all of these are examples of mixed fractions. So we have 8 and 2/3, 1.5, 5 and 1/5, and 100 and 2/9. So these are all mixed numbers. You're going to have this large number to the side, or this whole number, or this natural number to the side, and then you're going to have your fraction piece. So a mixed number is made up of two pieces. We have the whole number portion or the natural number portion, and then the fraction part. So let's consider the relationship between improper fraction and mixed numbers. So some improper fractions can be converted into mixed numbers and vice versa. So let's consider this example that we have in front here. We have 24 over 5, or 24 fifths. So how we convert, we're just going to look at how we convert that into a mixed number. So what we do, we take our improper fraction. So we have 24 over 5. And then what we do is we tell ourselves, how many times can 5 go into 24? So a prerequisite of doing fractions and conversion of fractions is timetables. So you have to be very good with your timetables. You have to learn, you have to understand it in order to be able, or in order for fractions to be a little easier. So if we know our 5 timetables, we know that 4 times 5 is 20, 5 times 5 is 25. So that means that 5 can only go into 24 4 times. So if we want to convert, we will say that we have 4 wholes, and then the remainder, we put that over 5. So 24 take away 20 will leave us with 4. So we take that 4 and put that over our original denominator. So therefore, 24 over 5 as a mixed number is 4 4 fifths. Right, so let's look at another example. So we have 10 over 3, or 10 thirds. So we add it to 24 over 5, and got that to be 4 4 fifths. So let's look at 10 over 3. So we have to tell ourselves, how many times can 10 be divided by 3? So we know that 10 divided by 3 is 3 with a remainder of 1. So we take that remainder and we put that over our denominator, which is 3. So if we check back, 3, which is our whole here, multiplied by 3 is 9, plus the 1 on top is 10. So that works out. So it's 3 and 3. The next example we have is 49 over 12. So if we take 49 and divide it by 12, we must tell ourselves, how many times can 49 be divided by 12? So 49 can be divided by 12 4 times, the remainder, not 1, because 4 multiplied by 12 is 48. So 4 times with a remainder of 1. So what are we going to do next? Right, you've guessed it. We're going to take that 1, we're going to put it over 12. So 49 over 12 can be converted. The mixed number that it's converted into is 4, 1 over 12. The next improper fraction we have is 36 over 6. So what we do, we ask ourselves, how many times can 36 be divided by 6? If you know your 6 timetables, you know that's 6 times. So 36 divided by 6 is 6. and you are left with no remainder. So a remainder of 0. So we don't write the 0. We don't write 0 over 6. No, we don't write that. We don't do that. We just leave, if our remainder is 0, we just leave the whole number that we got. That's all we do. So what we end up with is not a mixed number. In situations like this, we don't end up with a mixed number, we just end up with a whole number. So if we have a remainder of 0, we just end up with a whole number. So 36 over 6 gives us 6. 6 can go into 36 6 times. So next we have a mixed number. So we're going to look at that vice versa. We're going to bring that mixed number into the form of an improper fraction. So when we have mixed numbers, what we do, when we have mixed numbers, I want to convert it. I'm sorry, I stopped sharing the right. So if we have, sorry, my apologies. If we have a mixed number, I want to convert it. So this one's 4 and 4. Just on the right back. This is 3 and a third. This is 4, 1, 12. So just a whole circuit. So if we have a mixed number and we want to bring it to or convert it into improper fraction, what we do is take our whole number and multiply it by our denominator. So 3 multiplied by 7 will give us 21. And then we add our numerator. So 21 plus 5. And we're going to put all of that over our denominator, which is 7. So then our final answer, 21 plus 5, will give us 26 over 7. And that's our improper fraction. Because we know that improper fractions is where the numerator is larger than the denominator. So you see, it is important to know your tables. Because to bring that mixed number to an improper fraction, I have to multiply, or we have to multiply our whole number by the denominator. And then we're going to take the result of that and add it to our numerator. So 3 by 7 is 21, plus 5 is 26. I'm going to put that over our denominator, which is 7. So 3 and 5 sevens works out to be 26 over 7 if we're converting it to an improper fraction. So now we're going to talk about like fractions. Like fractions are fractions that have the same denominator. Like fractions are fractions that have the same denominator. So let's look at this list of fractions in front of us. Let's look at the list of fractions. So we have a combination of fractions. We have unit fractions in there. We have proper fractions. We have improper fractions. We have mixed fractions. We have a variety of fractions in front of us. But can we pick out what are the like fractions? So remember, like fractions are fractions with the same denominator. We know that denominator, our little clue, is that the denominator is the number that is down below. So let's look at the first fraction, 1/8. So now we have to pick out all the fraction that has 8 as its denominator. So if we look at the list, we'll see that there's 7/8 and there is 1 3/8. So yes, that is a group of like fractions. So 1/8, 7/8, and 1 3/8 are all like fractions because they all have the same denominator. So let's look at the second fraction we have on our list. We have 2/5. So like fractions will be any fraction that has a 5 as a denominator. So if we look at the list, there's only one more fraction, which is 8/5. That's an improper fraction, but it's still a fraction that has the same denominator as 2/5. So 2/5 and 8/5 are like fractions. So let's look at the third fraction we have on our list, 3/14. Are there any other like fractions? Are there any like fractions to 3/14? So the only fraction we have left in the list is 8/15. So 3/14 and 8/15, they are not like fractions. Like fractions must have the same denominator. So now let's talk about unlike fractions. So unlike fractions, just like our last examples, are fractions where the denominators are different. So let's look at, there are three groups of fractions. Can you determine which group is a group of unlike fractions? So remember, for unlike fractions, the denominators are different. And yes, you've guessed correctly. The second group, so that group in the purple box, that is a group of unlike fractions. So the first group, all of our fractions are tenths. So we have, in that group, we have a mixed number, a unit fraction, or a mixed fraction. So mixed fraction and mixed number can be used interchangeably. So we have a mixed fraction, a unit fraction, and an improper fraction, but all of those are tenths. So we have 3 and 3/10, 1/10, 27/10. So that's like fraction. So that is not a group. That does not fall into this category. And the third group are all fraction, all fifths. So we have 1/5, 2/5, 3/5, 25/5, 17, and 4/5. So these are all like, they are not they don't fall into the group. So unlike are different denominators. So here we have quarter, we have 4 and 4/16, we have 4 halves, and we have 3/4. So although these two are like, we still have two fractions that are not alike. So this group here, the second group, is a group of unlike fractions. So when you hear unlike, just different denominators, that's it. So next we're going to talk about equivalent fractions. So if equivalent fractions are unlike fractions, so more than likely they'll be unlike fractions. That's why I have unlike in brackets and in red. So they are fractions that have the same value. Fractions that have the same value. And of course, there are steps to determining whether fractions are equivalent, because if they are unlike, meaning that they have different denominators, it's going to be it's not going to be very straightforward to tell if they have the same value. So the first step, one way we can determine, is that we convert these fractions into like fractions using the LCM method, so the lowest common multiple method, which you'll find out about later on. And then we compare. Or we can multiply or divide the numerator and denominator by the same number, then compare them. So these are two ways that we could try to work out to see or analyze to determine whether fractions are equivalent. Two or more unlike fractions are equivalent. So of course I'm going to do the two ways. I'm going to use the two methods, and then you will determine which method is easier for you. So we're going to look at some examples. So let's determine if these fractions are equivalent. So the first pair of fractions we have is 4/5 and 16/20. So we have to determine whether those are equal. So they have the same value. You have to determine whether or not they have the same value. So we're going to calculate that using the LCM method. So we have 4/5 and we have 16/20. So an LCM, as I said before, LCM is your lowest common multiple. So basically we have to find a number that is both a multiple of 5 and a multiple of 20. So of course we're looking at the denominator, because remember we said we have to convert them into a like fraction. So which means that our denominators have to be the same. So right now they are unlike because our denominators are different. So we have to find our common multiple, the smallest number that 5 can go into and 20 can also go into. So if we consider some multiples of 5, know that multiples, if we write multiples of 5 here, we have some multiples of 5, 5, 10, 15, 20, 25. And then if we consider some multiples of 20, know that they are 20, 40, 60, 80, 100. So if we look at the two lists, we have to look for the smallest number, that's where the lowest come in, that is common. So the lowest or smallest common multiple of both 5 and 20. So if you look at the two lists there, you would see that 20 is the common multiple for 5 and 20. So in order to turn them into the like fractions, 20 is going to be the new denominator. So 20 is going to be our new denominator. So we've looked at the lowest common multiples of both 5 and 20, and we're saying that 20 is going to be the new denominator. So basically, all we have to do now is take that 4/5 and turn it into 20ths. That's all. Or if we know that 20 is going to be our new denominator, we're just going to convert 4/5 into 20ths. So you're going to say, how many times can 5 go into 20? That's 4 times. And we're just going to multiply our numerator by the results. So 4 multiplied by 4 is 16. So that means that these two fractions are equivalent. So 4/5 is equal to 16. Yes. So they are equal. The next set we're going to look at is 1/6 and 3/24. So 1/6 and 3/24. So we have to look for the LCM of, so the lowest number that is common, that is a common multiple of both 6 and 24. So we're going to talk about the multiples, and multiples just mean that we're multiplying 6 continuously. So multiple comes from that term multiply. So if we have 6, then our multiples of 6 are going to be 6. So 1 by 6 is 6, 2 by 6 is 12, 3 by 6 is 18, 4 by 6 is 24, 5 by 6 is 30. So this is why I told you before, timetables is a very important prerequisite. You have to know your tables. So these terms like LCM, and you will learn it on HCF, they are just terms, but they are so much easier when you know your tables. So if we talk about 24 and we consider the multiples of 24. So you have to be able to count in 24s. You're going to have 24, 48, 72. So just looking at the first 5 multiples, 96, and 120. So those are the first 5 multiples of 24. So if we look at the two lists, we can see that the common multiple between the two of them, the smallest common number, is 24. So that means our new denominator is going to be, for our both fractions, is going to be 24. Our new denominator is going to be 24. So this is the first method. We're using the LCM method. So since this fraction is already in 24ths, that means we just need to convert 1/6. So we have to bring that to 24ths. So we have to tell ourselves how many times can 6 go into 24, or how many times can 24 be divided by 6? And we know that answer is 4. So we take that 4 and we multiply it by our numerator of 1. So 1 by 4 gives us 4. So if we look at the other fraction that we have, they are not the same. So 1/6 is not equivalent to 3/24. They are not equal, because 1/6 is equal to 4 over 24. So they are not equal. So we've done those two using the LCM method. So 4/5, we were able to calculate that that is equal to 16 over 24. 1/16, we calculated that that is not equal. So that's the difference. So pay attention to the difference in how we write the equal sign and how we say not equal to. So this is equal, and not equal to is just the equal sign, a stroke running diagonally across. So 1/6 is not equal to 3/24. So now we're going to do the last two examples using the second method that we talked about. So they said divide the top. So you're turning the numbers into like fractions. So what you're going to do is just either multiply or divide the numerator and the denominator by the same number. So how are we going to do that? Let's look at that. So our third example there, we have 7/11. And we have to determine whether this is equivalent to 28 over 44. So in order to determine what number we're going to multiply or divide by, so we can make a decision. So let's look at the first fraction. We have 7 and 11. So if we just consider either the numerator or the denominator, we can see that 7 is smaller than 28. So if I want to move from 7 to 28, I have to multiply, because 7 is smaller, 28 is larger. So I have to multiply to move from 7 to 28. So then I'm going to ask myself, what do I have to multiply 7 by to get 28? And of course, this is where your tables are going to come in handy again. I know that 7 multiplied by 4 will give us 28. So if I'm multiplying 7 by 4 to get 28, then I have to multiply my denominator by the same number. So if I multiply my denominator, which is 11, by 4, I must get 44. So if we look on the other side and we see that that is what it is, 44, then that means that our fractions are equal. So similarly, I could have done the denominator first. So I could have said, okay, to move from 11 to 44, I have to multiply, but how much do I have to multiply by? I have to multiply by 4, because 11 multiplied by 4 will give me 44. So that means I have to multiply the top or the numerator by the same 4. Because remember, they said you have to multiply or divide the numerator and the denominator by the same number. So if I do it first down below, then I have to just take that same number and multiply it on top. Excuse me. So 7 multiplied by 4 will give me 28. So once it works out, that means that our fractions are equivalent. Because if we look here, we are multiplying by the same number. So that means that our fractions are equivalent. So based on the two methods, you can determine which one is easier for you. Those are just two ways to find out if fractions are equivalent, to determine, if fractions are equivalent. So 7/11 is equal to 28 over 44. And the last example we have is 9/12 and 3/4. The two fractions we have 9 over 12 and 3 over 4. So then, if we look at the first fraction, we have 9 on top, and then 3 on top. And if we look at the denominator, we have 12 and we have 4. So I know to move from a larger to a smaller, I cannot multiply, I have to divide. So if we look at the numerators first, I'm going to tell myself, how do I get from 9 to 3? So we know 9 divided by 3 will give me 3. So therefore, I have to divide my denominator by the same number, which is 3. 12 divided by 3 will give me 4. So the fact that we have divided by the same number, this means that these two fractions are equal. So that's the thing. When we're using this method, once dividing or multiplying by the same, both in numerator and denominator, by the same number, gives you the values on the other side, that means that those fractions are equal. And I mean, I could have done it in reverse. I could have said, okay, I could have done in the denominator first. To get from 12 to 4, I know that I have to divide by 3. So 12 divided by 3 will give me 4. And if I divide 9 by 3, I'll get 3. Or even in reverse. How do I get from 4 to 12? I have to multiply by 3. Likewise, to get from 3 to 9, I have to multiply by 3. So we've done the same thing. We have used the same number. We have multiplied by both our numerator and denominator by 3. So therefore, that fraction is, those two fractions, are equal. Those two fractions are equal. So of course, these videos will be recorded and posted on our YouTube channel. So if you have to go over, you can pause, you can try to do them on your own, you could rewind, etc. And of course, if you have any questions or concerns, feel free to comment or send a message in the chat. So now we're going to look at addition and subtraction of fractions. So let's consider the steps. So the first step, so we've covered all of the types of fractions. Now we're going to look into addition and subtraction of fractions. So the first step is to make the denominators the same or find a common denominator. So that means, of course, if they have the same denominator, that means we're going to turn them into like fractions because we remember that from our definitions, right? And then the second step, convert mixed numbers to improper fractions. So we know how to do that. That is something that we also covered. So of course, when you have your questions, you're going to, and the reason why those two are in teal instead of black is because that is saying to you, you may not have to do those steps. So you have to examine your question. If you need to, you're going to convert them into like fractions. And if you need to, you're going to convert mixed fractions into improper fractions. You may not have to. The next step is that you're going to add or subtract the numerator only. So you're going to keep the denominator. You're not going to do anything with that. So add or subtract the numerator only and simplify the result using the HCF or the GCF. Using HCF or GCF. So highest or greatest common factor. We're going to look at that. So addition of fractions. So let's add our first fraction. So they told us that the first step is to convert these. So if you look at the two fractions, this first one is an improper fraction. This one is a proper fraction. So we have no mixed numbers. So we don't have to do that. The next step would be to turn them into like fractions. So if we look at the denominators, they are different. So we have to turn them into like fractions. So that means we have to have one denominator. So we're going to have 17 over 7 plus 2 over 3. So let's talk about so if we have to turn them into like fractions, of course, we have to find the LCM. So the LCM of 7 so we look at the first 5 or so. So 7, 14, 21, 28, 25, 42. And then for 3, we have 3, 6, 9, 15, 18, 21. So of course, if we look at the two lists, we have to look at the smallest number. So lowest is common. That is a common multiple of both lists. So if you look at that, we'll see that we have 21 here, 21 here. So 21 would be the new denominator for our two fractions. So 21 will be the new denominator for our two fractions. So if I want to convert 17 over 7 into 21, what I will do, I will say, how many times can 7 go into 21? I know it's 3 times. And then all I have to do is just multiply 17 by 3. So think about it. If I'm multiplying 7 by 3 to get 21, then I have to do the same at the top. Because remember, we talked about like fraction. We say whatever you do at the bottom, you have to do at the top. So all I'm going to do is just multiply 17 by 3 and get 51. And then we're going to add that to, so we also have to convert 2/3 to 21s. So how many times can 3 go into 21? I know it's 7 times, and 7 multiplied by 2 is 14. So once we've turned them into like fractions, the next step they told us is that we have to add the numerator and keep the denominator. If we keep in the denominator, we know the denominator is 21. And if we add 51 to 14, we'll get 65. And then the next step is that what they told us is to simplify. So simplify means that you're not going to leave it as an improper fraction. You're not going to leave it as an improper fraction. What you're going to do is turn that improper fraction into a mixed number. So that's the next step. So if we ended up with 65 over 21, that's our result. We now have to convert this. We have to simplify. So we have to convert it into a mixed number. So basically, we have to ask ourselves, how many times can 65 be divided by 21? How many times can, or how many times do we sorry, yes, 65 be divided by 21. Yes, sorry, my apologies. So if we divide 65 by 21, we would get 3 with a remainder of 2. So we get 3 with a remainder of 2 because 21 multiplied by 3 will give us 63. So we'll have a remainder of 2, and we just put that over 21. So we have 3 and 2 over 21. So 3 and 2 over 20. So we've added those fractions. So added 17 and 2/3. 17 over 7, sorry, and 2/3, and we've got 3 and 2 over 20. So we have 2 more questions, 2 more examples for addition. So we have 2 1/4 and 3/4. So what they told us is that we should turn all of our mixed numbers into improper fractions. So that's the first thing we're going to do. So we have 2 1/4 plus 3/4. So we've examined it and we've seen that we have one mixed number. So we can turn that into, so let's pull it to the side. So we have 2 1/4 and we want to turn that to an improper fraction. So 2 multiplied by 4 will give us 8 plus 1. We put that over our denominator, which is 4. So 8 plus 1 is equal to 9. We put that over 4. So 2 1/4 is equal to 9 over 4. Right, good. And now they're adding that to 3 over 4. Next step they told us is that we have to turn them into like fractions. So if we look at this, we already know that they're already like, because both of them have 4 as the denominator. So all we're going to do is add our numerators and keep the denominator. So if both of them are quarters, we're just going to put 4 there, and 9 plus 3 will give us 12. And now we have to simplify. So if I have 12 over 4, then I have to ask myself, how many times can 12 be divided by 4? So 4 can go into 12 3 times with a remainder of 0. So remember, we said that when we have a remainder of 0, we don't put that over the denominator. What we're going to end up with is a whole number or a natural number. So 2 1/4 plus 3/4 is equal to 3. So that's our final answer. And now we're going to consider the last set. So we have 14 over 8. So 14 over 8 plus 2 over 8. So if we examine this, we have no mixed numbers. And then if we look at it, both of our fractions are like. So this one is pretty easy. So we keep the denominator, which is 8, and then we add the numerator. So 14 plus 2 is equal to 16. And now all we have to do is simplify. So if we have 16 over 8, we have to tell ourselves how many times can 8 go into 16, and it's 2 times with a remainder of 0. So our answer is going to be 2. But have you noticed anything about addition of fractions? What have you noticed? So in addition of fractions, you can add any type of fractions. So you can add unlike fractions. You can add a mixed number to a proper fraction. You can add an improper fraction to a proper fraction. You can add like fractions. So it doesn't matter what type of fraction it is, you can add them and even subtract them to each other. It doesn't matter what type it is. So that is a point to note. Doesn't matter what type of fraction it is, you can add and subtract. So you're going to look at subtraction. We're going to look at the same three examples. So it's the same steps. We convert mixed numbers into improper fractions. We turn them to like numbers, like fractions, sorry. We subtract the numerator and we keep the denominator. And once we found the result, we simplify if we have to. So we have 17 over 7, take away 2 over 3. So when we did it before, we knew that the LCM of 7 and 3 is 21. And then when we calculated, we got when we converted, we got this as 51 to 21. And we got this as 14 over 21. So all we have to do is keep the denominator and subtract the numerators. So we want to subtract 14 from 51. So 51 take away 14 and you'll get 37. So 51 over 21 take away 14 over 21 gives us 37 over 21. And now we just have to simplify because it's an improper fraction. So we want to make it a mixed number. So we know that 21 can go into, or 37 can be divided by 21. And we know that that will give us a result of 1 to 37. So 21 can go into 37 one time with a remainder of 16. And we just put that 16 over 21. So sometimes, so in this case, we got a mixed number, which is 1 and 16 over 21. Sometimes even the fraction portion of a mixed number can be reduced. So in some instances, it can be reduced. In this case, we're not able to reduce that. So we have 1, 16 over 20. So let's look at the second question. So when we converted 2 1/4 into quarters, so we have 2 quarters. We know that we have to convert that number into a proportion. So 2 multiplied by 4 is 8 plus 1 is 9. We get 9 over 4. Take away 3, 4. So 9 take away 3 will give 6. And we keep our denominator, which is 4. So all we have to do now is simplify. So if we have 6 over 4, that 4 can go into 6 one time with a remainder of 2. So we put that remainder over 4. And remember, I told you that sometimes when we have a fraction, when we calculate our mixed number, the fraction bit, sometimes we have to reduce, it can be reduced even further. So we've converted it into a mixed number. So now we can reduce the fraction portion of that mixed number. So if we have 2 over 4, we can reduce that or make it simpler. So we're going to hold the 1. Then if we take the 2 over 4, simplify. 2 can be divided by 2, just give us 1. And we also want to divide 4 by 2. So 4 divided by 2 will give us 2. So 2 over 4 is equal to 1/2. Last piece, and the last example we have is 14. 8 take away 2 over 8. So we don't have any mixed numbers. So, and both of these are like terms. So we just subtract the numerators, keep the denominator. So the denominator for both of them is 8. So our answer is 8. 14 take away 2 is 12. And now we're going to reduce. So 8 can go into 12 one time. A remainder of 4. Put that 4 over 8. And of course, 4 over 8 can be reduced. 4 over 8 can be reduced. So we're going to have 1. Just try to reduce the 4 8s, that 4 8 portion. So if we look at 4 and 8, we know it can be reduced because 8 is a multiple of 4. Or if we think about it, 2 and 4 are factors of both 8 and 4. So things like that will let you know that, hey, this fraction can be reduced. So if I divide 4 by 4, I'll get 1. And if I divide 8 by 4, I'll get 2. So 4 over 8 actually total 14 over 8 take away 2 over 8 gives us 1.5. Let's talk about multiplication of fractions. So steps, of course. We convert mixed numbers to improper fractions. We multiply the numerators, multiply the denominators, and we simplify or reduce using the HCF method. So I know that this session is a bit long and you're probably oversaturated, but we're almost done. We will start at division of fractions. And of course, once the recording has been converted, I would save or I will post the recording as 2 separate videos. So I'll try to split up the recording and post it as 2 separate videos. Right, so it's multiplication of fractions, we convert, multiply numerator, multiply denominator, and then simplify. So we're going to look at the same 3 questions that we have, just we're doing multiplication. So I have 17 over 7 and 2 over 3. So the first step they said is to convert mixed numbers to improper fractions. So in this particular question, we do not have any mixed numbers. All we have is an improper fraction and an improper fraction, sorry, and a proper fraction. So the next step is to multiply the denominators, sorry, the numerators, and then multiply the denominators. If we multiply the numerators, we have 17 by 2, that will give us 34. Tables coming in handy again. And then we have 7 multiplied by 3, that will give us 21. So we end up with an improper fraction, 34 over 21. So all we have to do now is simplify this. So all we have to do is simplify. So if we divide 34 by 21, we know that 21 can go to 34 one time with a remainder of 13 over 21. So 13 is a prime number. So it's a number that can only be divided by itself and 1. So therefore, this fraction definitely cannot be reduced. So our answer will be 1 and 13 over 21. And of course, in probably some videos, preceding video, I'm not sure, I may cover prime numbers so you have a better understanding, because I've already used the terms. I would want to talk about that with you. So let's move on to the next question. So we have 2 and a quarter multiplied by 3/4. So the first step, they said, that is listed, turn your mixed numbers into improper fractions. So we've done this question a million times. We converted that 2 and a quarter into an improper fraction, and we got 9/4. We're multiplying that by 3/4. So we multiply top by top, or numerator by numerator, and bottom by bottom, or denominator by denominator. So 9 multiplied by 3 will give us 27. And then 4 multiplied by 4 will give us 16. So we've ended up with an improper fraction. So we have 27 over 16. So of course we would want to convert that into a mixed number and reduce where necessary. So we know that 16 can go into 27 one time with a remainder of 11. So we put that remainder over 16. So 11 again is also a prime number. It can only be divided by 1 in itself. So therefore it's not going to have common multiples with much numbers. Only numbers that are probably divisible or that are divisible by 11. 16 is not divisible or cannot be divided by 11, so therefore this fraction cannot be reduced. So our answer is 1 and 11 over 16. So now we have our final question. So we have 14 over 8 multiplied by 2 over 8. So you have to calculate that. So we multiply top by top and bottom by bottom. 14 by 2 is 28, and 8 multiplied by 8 is 64. So therefore, I'm going to look at this fraction. It's not an improper fraction, it's a proper fraction. So basically, we just have to examine to see if it can be reduced. So if we look at 28, and we remember we spoke about HCF, so highest common factor. A factor is a number that can go into another number. So we want the largest number that can go into 28, that can also go into 64. So if we consider some factors of 28, we have 1, we have 4, we have 7, we have 14. Sorry, we also have 2. Then put that there. "28." I should have probably put 2 higher up. My apologies. If we consider 64, we have 1, we have 2, we have 4, we have 8, we have 16, we have 32, and of course we have 64. Right, so we have to look for the largest number that is common between. So we could probably underline all the common numbers. So we have 1 here that is common between the 2. We have 4 here that is common between the two. So if we look at the list, we have no other numbers that are common. So we want to get the highest common factor. So the factors are numbers that these numbers, 28 and 64, can be divided by. So the highest or the greatest common factor is 4. So that means to reduce it, we're gonna divide top and the bottom by 4. If we divide 28, sorry. So if we divide 28 by 4, we'll get 7. And if we divide 64 by 4, we'll get 60. So final answer is 7/16. So earlier on we spoke about LCM, now we're talking about HCF. So LCM is the numbers that when we multiply a number by itself. So we keep, if it's 2, we go 2, 4, 6, 8. But generally, the factors are the number or smaller. Multiples would be the number or larger. Right? So we're going to move on to division of fractions. So the steps involved, first we're going to convert mixed numbers to improper fractions. So of course, something you can note about multiplication and division is that they don't have to be like numbers. So when we did addition and subtraction, you have to convert those fractions to like fractions. With multiplication and division, you don't have to do that. So you convert mixed fractions to improper fractions. You change the sign to multiplication. You reciprocate the divisor. So the divisor is the number that you're dividing by. And you find the product and simplify. So of course, we're going to look at some examples so that I'll further explain what these steps mean. And of course, a tip that I like to use for division of fractions is keep, change, flip. So keep, change, flip. Remember that when you're doing division of fractions. So let's look at some examples. So I've kept the tip there, keep, change, flip. So let's look at the same 3. Well, let's look at 3 questions. So we have 17 over 7 divided by 2 thirds. So remember, the first step they told us is to change mixed numbers to an improper fraction. We don't have any mixed numbers, so we don't have anything to change. So we keep. So now we're going to move on to our tip that we have there. We're going to keep the first fraction. We're going to change that division sign to multiply. And then we're going to flip the second fraction. So that's what reciprocate means, to do the opposite or to flip or to, yes, to do the opposite or to flip. So we are finding the reciprocal of the divisor. So basically we're just flipping it. So if we have 2 over 3, when we flip, we're going to end up with 3 over 2. And then we're just going to multiply. So that's the same thing that we did for multiplication. So top by top, then bottom by bottom. So 17 by 3 and 7 multiplied by 2. So 17 by 3 it was 51, and 7 by 2 will give us 14. So we have 51 over 14. So now we just have to change this into a mixed number. So simplify and reduce. So we can't remember when we have fractions. So when you do your tests or you do questions, teachers may give you, when you get this result such as this, they may give you it right. But when you have questions that are worth 5 marks or 6 marks, you're going to lose a mark for not simplifying or reducing your fraction. So if you leave it as an improper fraction, you will lose marks. If you want to capitalize on those marks, you want to convert, right? So we have to ask ourselves, how many times can 14 go into 51? So 14 can go into 51 3 times. So we know that 14 by 3 will give us 42. So 51 take away 42 is 9. So we have a remainder of 9. And put that 9 over 14. So 9 14s cannot be reduced because 9 factors of 9, 1, 3, 9. Factors of 14, 1, 2, 7, 14. So the only common factor is 1, so we leave it as itself. So the answer is going to be 3 and over 14. So next we have 2 divided by 3/4. So we convert mixed numbers to improper fractions. So 2 multiplied by 4 is 8 plus 1 is 9. We put that back over 4 and then divided by 3/4. So now we apply that tip that I gave you. We keep the first fraction, which is 9 over 4. We change the sign from divide to multiply. And then we flip the second fraction or the divisor. So if we have 3 over 4, we're now going to end up with 4 over 3. So we're going to multiply top by top and bottom by bottom. Of course, because we have 4 here and 4 here, there are things that we can do to make it simpler, but I'm not going to confuse you with that. So top by top and bottom by bottom. So we have 9 by 4, which will give us 36. And then 4 by 3, which will give us 12. So we have to ask so now we have to simplify. Remember, I told you have to simplify. So we ask ourselves, how many times can 12 go into 36? So it's 3 times with a remainder of 0. So we don't put anything there. It's just leave a whole number. Great. So now we can do the third question. So we have 14, which is a whole number, divided by 8 over 2. So you probably would say, how come we're dividing a whole number and not a fraction? Remember, I told you in the earlier, remember I told you about things you should know about any number. Once you have a number, that number, if we want to write it as a fraction, we can put it, it is understood that that number is divided by 1. So if we have 14 divided by 8 over 2, we can rewrite that as 14 over 1 divided by 8 over 2. So we have no mixed numbers, so that means we can just go straight to the tip. So we keep the first fraction, 14 over 1 is the same as 14. We change sign from division to multiplication, and we flip the divisor. So we have 8 over 2. We're going to end up with 2 over 8. Now we can calculate this top by top and bottom by bottom. So 14 divided by 2 will give us 28. And 14 multiplied by 2 give us 28. And 1 multiplied by 8 will give us 8. So we'll end up with an improper fraction, which is 28 over 8. So now we can reduce that fraction. So we know that 8 can go into 28 3 times, because 3 by 8 is 24, with a remainder of 4. So we now have 4 over 8. So we have 3 and 4 over 8 can be reduced. So 4 can be divided by 4, and 8 can also be divided by 4. So that's the largest number that both of them, for the 8 CF of 4 and 8 is 4. So the largest number that 4 and 8 can be divided by. So 4 divided by 4 will give me 1, and 8 divided by 4 will give me 2. So 4 eighths is equal to a half. So my answer is 3 and a half. And of course, that brings us to the end of today's session. I'm not going to overwhelm you, because I know I've done that enough. And don't forget to like, subscribe, and share this with anyone who can benefit from all that we've covered today. And I've covered a lot. So remember, I will try my best to edit and split this video into 2. So join me next week for another session of math days. I hope that what I did today brought great benefit to you. So see you next week. Have a good evening. Bye.